When light interacts with matter, there are the three possible processes. One is absorption, second one is spontaneous emission, third is the stimulated emission. That is the need of the any laser. So today we are understanding the construction and working of carbon dioxide laser, CO2 laser. This CO2 laser is fabricated and designed by an Indian scientist whose name is Kumar Patel in the Bell Laboratories of US in the year 1964. This is the first gas laser was designed, and this is one of the most useful and regularly used layer all over the world. This carbon dioxide laser provides the highest power continuous wave laser. The CO2, the carbon dioxide laser, has able to produce two wavelengths, that is two lasers of wavelengths 9.4 and 10.6 micrometers. So this carbon dioxide laser, here in this carbon dioxide laser, there are two possible laser can be produced. One is the 9.4 and other one is the 10.6 micrometers. They both fall in the infrared region. Now, out of these two, one of them is chosen, and that is made to get the stimulated emission. See, you got two of them. So one of them you make it, you choose one of them, and you allow that that is the distance between the two mirrors such a way that L is equal to n times lambda by 2, where lambda is the wavelength that you and that gets multiplied. If you choose the wavelength lambda 10.6 such a way that the distance between the two mirrors should be adjusted. So by adjusting the mirrors between the cavity, laser cavity, you can choose one of them and that gets multiplied. Okay. So now this carbon dioxide molecule is having three modes of vibration. So this carbon dioxide molecule is not simply just as it is, it is vibrating about its mean position. So it is having three kinds of vibration. I'll show you that diagram. See, this is the vibrations of carbon dioxide. Look at here, in one of the vibration, carbon atom is at the center, two oxygen atoms, they are vibrating to and fro, keeping this carbon is stationary. That is the symmetric stretching mode. So this where only oxygen atoms vibrates, leaving the carbon atom. The frequency of this symmetric stretch is 4 into 10 to the power of 13 hertz. The frequency of vibration of this symmetric stretch is 4 into 10 to the power of 13 hertz. And the center one is the bending mode, where carbon dioxide is moving up, and see that oxygen atom is moving down. When carbon oxygen atom moves up, carbon moves down, like that. So they are moving up in opposites. So that particular stretch is called the bending stretch. So this is another kind of vibration, and the frequency of this bending mode of vibration is 2 into 10 to the power of 13 hertz. Coming to another kind of vibration, that is called asymmetric, where all the atoms are vibrating. Look at carbon is moving at one direction, that is opposite to the oxygen atom. So both the oxygen atoms moves one direction while the carbon moves opposite to that. So that is the kind of vibration. So in a carbon dioxide, if you take carbon dioxide molecule, there are three possible vibrations. So all these, I mean, carbon dioxide molecule vibrates in three different directions, or the vibrates in three different ways. One is symmetric vibration, other one is bending vibration, third one is asymmetric stretching mode. The frequency of asymmetric stretching mode is 7 into 10 to the power of 13 hertz. So this is how the carbon dioxide is vibrating in space. Okay. So now coming back to these modes of vibration, so those three modes are called symmetric mode, asymmetric mode, and bending mode. Carbon dioxide molecule is vibrating in three different modes. CO2 molecule or carbon dioxide, say now how do you know that which particular vibration is allowed in a lasing action? It is not so. Like it is always the combination of all the three modes. So you cannot take just only one mode. You cannot restrict the carbon dioxide molecules to vibrate only in symmetric mode, or you cannot restrict only for asymmetric or bending mode. So this carbon dioxide molecule is vibrating in all three possible the vibrations, and their vibration frequencies are kept on giving it. Okay, so therefore the carbon dioxide molecule is vibrating as a combination of all the three. It's a linear combination of all the three vibrations. When a carbon dioxide molecule is vibrating means it is vibrating all the three modes. It is a linear combination of all the three modes. And here these vibrations, I told you, it is vibrate to certain frequencies. Symmetric is vibrating at 4 into 10 to the power 13 hertz. Bending mode vibrates at 2 into 10 to the power 13 hertz. Asymmetric vibrates at the frequency of 7 into 13 hertz. So these are the definite values. So these vibration frequencies are fixed. So that is, carbon dioxide vibrating in symmetric mode has a definite frequency. The one which is vibrating under in asymmetric mode has got another frequency that is fixed. These frequencies are fixed, and this always vibrates with only these frequencies. And while you look at this the spectrum, you have all these three modes, and the three frequencies can be seen in the spectrum. Therefore, carbon dioxide is vibrating in all the three modes. And how to consider these vibrations? In any case, carbon dioxide is the linear carbon dioxide is vibrating with a linear combination of all the three modes. All the three modes you will see in the spectrum. So that is how the carbon dioxide molecules already seen that how it is vibrating. Okay, so coming to the exact construction of the carbon dioxide laser. So this is the schematic diagram of a carbon dioxide laser. So it contains, look at there, you got two mirrors. One is fully reflecting mirror at the left side. On the other side, you have got the partially reflecting mirror through which the lasers you come, you know that. And it is a discharge tube. It is an electrical discharge tube, and DC supply is allowed. So to this, when you apply high tension voltage, DC voltage, electron starts moving from one electrode to the other electrode. You see that just like the spark, the sparks are produced. Sparks means the electrons move from one electrode to the other electrode. Since because high voltage, the sparks, the electron starts moving from one electron to the other electrode, and within the discharge tube you have a mixture of three gases. We call here it is carbon dioxide laser. That is, CO2 is the active centers where you will get the stimulated output. So other molecules, that is other gas, helium and nitrogen is also there. They don't directly involve in giving the mm, laser. They don't give directly the emissions of photons. They help carbon dioxide molecules to excite. From there you will get the laser output. Okay, this carbon dioxide is a mixture of three gases. I mean, carbon dioxide laser is is a mixture of three gases within the discharge tube. And look at the discharge tube. I got two these Brewster's windows, sodium chloride Brewster window on right side, and left side it's not marked but got sodium chloride Brewster's windows. They are kept at Brewster's angle so that any output that is coming out of this window is polarized. It means you can get the polarized output with respect to the carbon dioxide laser also. So it means you can get a polarized carbon dioxide laser output is also possible if you keep the sodium chloride the windows Brewster's window at Brewster's angle. Okay. So now this carbon dioxide laser contains look at here. So it is a discharge tube of length 5 meter and has got the diameter of 2.5 centimeter, and two Brewster's windows are attached at the ends of the discharge tube. The discharge is produced by high tension voltage. Once the discharge is produced, electron starts moving from one electrode to the other electrode, and within the discharge tube you have carbon dioxide, nitrogen, helium at different pressures. Here it is 1 is to 4 is to 5 atmosphere pressures, and again these pressures may change depending upon the dimensions of the tube. If you change the dimensions of the length of the tube to other than 5 meter or the diameter is other than 2.5 centimeter, you need to calculate the corresponding proportions by some other formula. Okay. Therefore, correspondingly, you need to fill up the gas inside the discharge tube. Okay. This is about the construction of the carbon dioxide laser. Now, so this is about the construction of the carbon dioxide laser. That's how the system CO2 laser overall system looks like. So now how it works, how is it possible to get the laser output with this setup, experimental setup. So you have seen the diagram. You got a discharge tube. Inside you have different gases along with the carbon dioxide. You got nitrogen and the helium, and sometimes water vapor is also filled up. I'll show you the diagram now. Energy level diagram. 1 minute. So this is the energy level diagram. Look at the energy level diagram. So one side to the left side you got the nitrogen energy levels. On the right side C1, C2, C3, C4, C5, they are the energy levels with respect to carbon dioxide. Left side N1, N2 is with respect to nitrogen. On the right side you got the carbon dioxide energy levels. Here when you apply the high tension voltage from external. Now here for a laser you know that there are three basic components to get a laser. What are they? The one is the actinium, second one is the pumping agent or the external source, and the third one is resonant cavity. So is it or the laser cavity. So now when you send high voltage DC supply, the electron starts moving from one electrode to the other electrode. So while on its move, when these electrons moving towards other electrode, it will collide with the nitrogen atoms. Look at here. Now, when the electrons collides with the fast moving accelerated electrons from one electron to other electron that is going, it collides with the nitrogen atom. When it collides with the nitrogen atom, the nitrogen atom is now getting excited to N2. See that? It was in ground state N1. When electrons collides with that, it picks energy from the electron and goes to the level N2. Now this N2, is the excited state for the nitrogen. So now in the overall system, you have carbon dioxide molecule also. And now this agitated or the molecules at N2 level, that is nitrogen molecules at N2 level, now got the high energy. Now this collides with the nearby or the neighboring carbon dioxide molecules. When this nitrogen atoms collides with the carbon dioxide molecules, it will transfer its energy. So now the nitrogen, see here, nitrogen got energy and moved to N2. So it got the energy now. So now this energy is transferred to the carbon dioxide molecules by colliding. This is called the inelastic scattering here. So now when nitrogen collides with the neighboring carbon dioxide molecule, there is a resonant transfer of energy. We call it as the resonant transfer of energy. You know that meaning of resonance, where you got two things, the matches, if it is the frequencies, two frequencies match, and then you will go into the other side like that, where here the energy levels at N2 and energy level at C5, they are almost equal. Therefore, it will be transferred from the N2 to C5. So now, when nitrogen collides with the nearing carbon dioxide molecule, it will transfer its complete energy. It is called the resonant transfer of energy to the carbon dioxide molecule. Here, the C5, when it goes to C5, when the energy transfer to C5, that is carbon dioxide is at right now is at the excited state. See now what is happening here? The nitrogen is transferring energy to carbon dioxide molecule. So hence the carbon dioxide molecules got excited to C5. So C5 is the excited state. It is excited to C5. So this C5 is the uh, metastable state here. Okay. So the C5 is having the characteristics of a metastable state. You know that to get a laser, this laser system should have a metastable state. You know that metastable state has got the lifetime of 10 to the power minus 3 seconds, around milliseconds, and ordinary excited state has got that around few nanoseconds. So this since the C5 is a metastable state, the atom, you can see here, by continuously discharging electron to by continuous electrical discharge, you can continuously move the nitrogen atoms to N2, that will collide with the C5, so that's collected at C5. This can be done continuously. So by continuously discharging the electrical discharge here, nitrogen atoms are continuously going to N2, that is transferring to C5. So again, the other nitrogen atom picks energy, goes to N2 and drops at C5. It's like that. You will see within a small fraction of time, there will be a large number of atoms that have been sitting at C5. Since it is C5 is a metastable state, there will be large number of atoms, they are sitting at C5. When compared to the lower level C4 and C3, the number of atoms at C5 is becomes large. You know that this is the situation of population inversion. So in order to get a laser, you already learned. So there should be a metastable state. When there is a metastable state, that helps to build up the population inversion. Now the population inversion has been created between C5 and C3 and C5 and C4. So any transition that is from, I told you in carbon dioxide laser, you have two probable wavelengths. So two probable lasers can be generated, one with 10.6 and other one is 9.4 to 9.6 micro. So now any transition that is between C5 to C4 will result in a emission of 10.6 micro. This is an infrared radiation. Okay. Again, any transition, another possible transition is from C5 to C3, that leads to 9.6 micron. So you got two laser. You choose whichever you like to have a laser. So that can be done by adjusting the resonant cavity, that is a mirror between the media active medium, such a way that it is integral multiples of lambda by 2, where lambda is either 10.6 you choose, or 9 point, the point something is can be chosen. Whichever the laser you choose, that particular the laser gets multiplied. Only that particular laser is stimulated, so produces a large number of stimulated emissions, and hence you will get that particular laser. So now once that such a laser is produced, now either it is in now the particle, that atom is either it is C4 or C3. So now when these are C4 and C3, it has to come down to C1. So now they are sitting at C3 because here this IR output, see here, this IR, this is IR radiation 10.6 or 9.6, it is IR radiation. This will create heat. So thus to some extent some heat is generated within the tube. So the heat has been generated in the tube. Now this heat has to be cooled down. So that is the discharge tube, because of higher radiation produce some there creates this generates heat. This heat has to be taken out. This heat will be taken out by continuously blowing helium. See, you got the mixture of nitrogen, carbon dioxide, and helium, isn't it? So now you are also blowing helium into this mixture. I mean, into the discharge tube. This helium picks up energy. This helium is a good thermal conductor. The helium atoms or the gas picks up energy, and that is coming out. So the heat is taken out, just like AC, heat is taken out, and always it tries to maintain the discharge tube in a under cooled state. So now when it is cooled, now the atoms are at C3 and C4, then they will make a downward transition to C1 by colliding with the walls of the tube. When they collide with the walls of the tube, they lose its energy. So now the carbon dioxide atom is brought down to C1. So this is one cycle of radiation where a photon is released. You know that is since when there is a population inversion at the metastable state, there will more number of atoms. You already learned there will more number of atoms sitting there. Any spontaneously created photon will create a bunch of the photons. You know that. So now the photon, this will complete that is atom, that is nitrogen atom picking energy going to N2, then transferring to C5. There you have the photon, that is a laser. Then is coming down to C1. It's one cycle. Since continuously producing, since you are continuously discharging the tube with the electrical supply, more and more nitrogen atoms are moving and they collide with the carbon dioxide molecules. So there it sits in the C5. So there more number is created. So from there the laser, say the 10.6 or 9.6 is being related. So it can produce continuously. So this carbon laser is a continuous wave laser. That's how you can produce the carbon dioxide this laser output. We'll go back to the slides and I'll explain. When an electrical discharge is passed through discharge tube, the nitrogen molecules in the ground state absorbs energy from the moving electrons between the electrodes and excited to N2, that is N2 level. The nitrogen molecule in the N2 level now undergo an inelastic scattering with the neighboring CO2 molecule to their ground state. So it picks up energy and transfer to CO2. As a result, a resonant transfer of energy from nitrogen to carbon dioxide molecules takes place. I told you at resonance two things matches. Here the energy is matching. Look at the when you looked at the energy level, the position of N2 and the position of C5 they are almost the same level. So the energy levels are almost equal. Energy of N2 is equal to the energy of C5. So this is a resonant case. So now the energy is completely transferred to C5. So see that C5, you have seen that C5 is a metastable state of carbon dioxide molecule. Therefore, the population at C5 is increases. Population inversion is achieved between the C5 and C4 and as well as C5 and C3. So now two photons of 10.6 and 9.6 created from these two transitions. A spontaneously created photon will prompt the stimulated emissions. You know that. The photons now, once they are released, they are bouncing back between the two mirrors. You have seen that you required, there are two mirrors there. Okay. They are moving in between these two. So, and as they move, run, it's reflected between these two, it starts creating more and more and more stimulated emissions. So, it is producing more and more stimulated emissions. Therefore, a large number of photons have been created in a very short interval of time. The transition from C5 to C4 results 10.6. The transition from C5 to C3 will give you 9.6. You choose one of them, such that I told you, but keep adjusting the mirrors between the, adjusting the mirrors so that it satisfies L equal to n times lambda by 2, where lambda is the wavelength of source, laser. Right? Selection of particular wavelength lambda of the laser can be made by adjusting the distance L between the mirrors such a way that m, that is integral multiples of lambda by 2. As the gas mixture heats up, it may spoil the population inversion at C5. Therefore, by blowing helium gas or water vapor continuously, the heat generated in the tube can be removed. The carbon dioxide now returns to ground state and again it's ready to take up the can go to excited state. You know that as a population inversion is maintaining continuously, you can generate the continuous wave laser. So now what are the features of this CO2 laser? It is said to be 4-level laser. I'll tell you how it is. It is a 4-level laser. And in a medium, the active medium, CO2 molecules are the active centers where we have seen the required laser output you are getting it either 9.6 or 10.6 wavelength that is created in the CO2 molecule. The CO2 molecules are the active centers. And then the electrical discharge is the pumping agent. You have used the high tension, high voltage DC supply. So it is a good, it's a highly efficient carbon laser having up to efficiency 40% and the output, the intensity, power output is around a few kilowatts and it gives you a continuous wave laser. It is just like when you, switch on the lamp, you have got, switch on the battery, you have continuous light now. As soon as switch it off, it gets off. Like that, As soon as you switch it on, the high tension the DC electrical DC supply within the mixture of these gases under these suitable conditions, you will see that you will get the continuous output. Continuously you can produce the wave laser output. So what are the advantages? Coming to the advantages, I told you it is the most efficient, widely used uh, laser in particularly in industry. The CO2 laser is are used to weld the materials, cutting of materials and drilling of metals. It is done there. And their CO2 lasers are also used in the surgery, like scene surfacing, uh, like if scene is the skin, if you have any scar, etc., some marks, etc., then you can remove the mark on the screen on the skin by this technology laser using CO2 laser. You can remove any marks that has been occurred due to some accident or due to some burning of skin, etc., can be polished and can be removed by using CO2 laser.